Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
Alrighty, let's take a look at our homework. First, for M&Ms, we've got just basically the term integers. Integers are whole numbers plus their opposites, and the only whole number that doesn't have an opposite of 0, but 0 is still considered an integer because of this rule. Now, a lot of times people think all the positives and negative numbers are integers, and they're not quite sure where 0 goes in that definition. And sometimes people will think 0 is not an integer, but it absolutely is, because 0 is one of the whole numbers. So you got your entire set of whole numbers and their opposites. 0 doesn't happen to have an opposite, but that still doesn't change the fact that it is a whole number. So all of these numbers, the whole numbers and their opposites, are considered integers. Now, notice we're not yet looking at the numbers in between. Integers are not any of the fractions or decimals, just the whole numbers and their opposites. So write an expression to represent each of the following sketches, then give the value of each sketch. Okay, so this is where we're using our integer tiles, and every time you got a positive and a negative together, they are going to cancel each other out and form a 0 pair. So how many zeros do we have here? We have 1, 2, 3 zeros, leaving us with only 2 positives. So the answer to 5 plus -3 is +2. Now, when you're only working with relatively small integers, you can draw this as a diagram, and it's very effective for helping you identify what you're supposed to do to get to the answer, right? You got some positives here, you got some negatives here. The positives and negatives cancel each other out with the zeros. So, it's a great illustration for why we do what we do when you add a positive number to a negative number. And that is, you end up subtracting the numbers and you keep the sign of the bigger number. So what I like to do with students is, when I'm asking them what is the answer to 5 plus -3, I ultimately ask, do you have more positives or do you have more negatives? In this case, we've got more positives, so your answer is going to be a positive. And the question is, how many more positives do you have than negatives? And how many more is a subtraction question. So 5 minus 3 is 2. And since you've got more positives than negatives, the answer is going to be a +2. Here you've got an illustration for 4 minus, what do you go backwards? 1, 2, 3, 4, 5, 6. Well, that's the same as saying 4 plus a -6. So if I were to draw the positives and all of the negatives, you can clearly see that you got more negatives than positives. How many more negatives do you have? Well, 2 more negatives than you had positives, so our final answer is -2. Okay, so that's using this model instead of the number line. When you're using a number line, it's just a matter of what was your starting point, and if you're subtracting, you go to the left. If you're adding, you go to the right. Unless you're adding a negative, in which case you do the opposite. So you're, instead of at 4 plus 6, you're adding 4 to the opposite of 6. So go in the opposite direction. It's like 4 minus 6 is going to take you into the negatives. Okay, and then here you're starting at -4, and you're going to go to the right 7 units. So it takes you 4 units just to get to 0, and another 3 units stops you at +3. All right, use the numbers 5, 6, and 7, and any of these operations: addition, subtraction, multiplication, and or division. So you don't have to use them all. You can just use 1 or 2 of them. And your task is to create 3 different expressions with 3 different values, but we want one of them to be 37. So that's pretty much the hard one, is figuring out how to get a combination of multiplication and addition, or any of those operations with these 3 numbers. And it does say to use the 3 numbers. Are we allowed to? Yeah, we're supposed to use all 3 numbers, probably one time. And so these are the other 2 expressions that I came up with. I'm sure you've got a few different ones that also work. You might even have another combination that gives you 37, but this is what I came up with. Use the number line to show your work as you find the value of each expression. Okay, so you're going to start at -5, and then you're going to add 3.25. So you're going to go 1, 2, 3 units. Oh, wait, hold on. What am I counting by here? 1, 2, 3 units, and then another quarter of a unit stops you right there. And this number is in the negatives still. That's why we got a negative answer. And this is how many units away from 0? 1 1/2, 1 3/4. So it's -1.75. Here you start at 3, and then we're at, or 3.18, and now you're going to add a -7, which is the same as going backwards 7 units. So we're a little bit to the right of the 3 here, so we're going to go 1, 2, 3, 4, 5, 6, 7. So now we're a little bit to the right of the -4, and it ends up being -3.82. Okay, now if we weren't using the number line, because I'm going to be straight with you, using the number line on problems like this, it's kind of confusing. So I would prefer that you think of it in these terms. Since you're adding 2 numbers that have different signs, you know you're going to do a subtraction. So let's just do the subtraction. And when you're subtracting decimal numbers, remember you got to line up the decimals. You got to make sure you've got digits matching in the 10th place and the 100th place. So now we have to do some borrowing. So I'm going to take that, make that a 4, and make this a 10. So now I can borrow from that, make that a 9, make this a 10. 10 minus 5 is 5. 9 minus 2 is 7, and 4 minus 3 is 1. And since we had more negatives than positives, our answer will be a -1.75. So honestly, in a situation like this, it's good to see it on the number line, but I'm not a big fan of trying to use the number line when we're dealing with decimal numbers. Just a little more complicated than I would like. All right, rewrite the following fractions as decimals and decide if they are terminating or repeating. Okay, so 7 divided by 8 is 875 thousandths, and that's where it terminates. So that is our final answer. It's a terminating decimal. Part B, 2 divided by 9 ends up giving you a repeating pattern, 0.2 repeated. 4 divided by 7, this is probably the worst one to have to show your work on. If you were using a calculator, it'd be so much easier. But it turns out it takes 6 digits before you start to see a repeating pattern. So this goes 571428, and it's going to go 571428, 571428. And you would see that on the calculator. What is that? 4 divided by 7, 4 divided by 7, 571428, 571428, 5714. The next digit would be 2, the one after that would be 8, and so on and so forth. And this one kind of looks like it would be a repeating decimal because you're thinking, well, 2 times 11 is 22. And didn't we say if there's anything in the denominator besides 2's and 5's, it would repeat? Except for one thing. Let me go ahead and do something here. 11 over 22, if you divide the top and the bottom by, not 2, divide it by 11, because that's the greatest common factor, then you end up with 1 in the numerator and 2 in the denominator. And now you do get a terminating decimal because you've only got a 2 in the denominator. So you don't want to make this decision about whether or not it repeats or terminates until after you've completely simplified the fraction. So 11 divided by 22 is 5/10 in decimal form, or 1/2 as a fraction, and it terminates. Evan's uncle gave him money for his birthday. Evan plans to put, I'm going to highlight here, half of the money into his savings account. He plans on spending 1/5 of it on bubble gum, hooray, and comic books with the leftover money. Okay, so it looks like half of the money is going into a savings account. The other half is either going to buy bubble gum or comic books. And we know 1/5 is going toward the bubble gum. So what portion of the money will he spend on comic books? Okay, so what we have to do is we have to add these fractions together. So 1/2 plus 1/5, you want to find a common denominator, which would be 10. And so that means that 7/10 of his money is going to be either put into savings or spent on bubblegum, which means the remainder of it would be spent on comic books. So you have to take 1 minus 7/10, or 10/10 minus 7/10 equals 3/10. Then it says Evan uses some of his comic book money to buy a magazine for $4. If he had $30, what fraction of this money will be spent on the magazine? Okay, so this one kind of looks like it's more complicated than it really needs to be, but he's got $30, right? And that would be $4 out of the 30 would be spent on the magazine. So 4 out of 30 is the same as 2 out of 15. Sometimes people think that problem's a little bit more complicated and you have to factor in all this other information. It's like, no, we know the total is 30. We know 4 out of that 30 is going to be spent on magazines. So this is the ratio in simplest form. And that's it. We're done for today. All right, so go get started on your lesson for today, and good luck on that. Take care. Bye. Bye.
Hey, feeling good, like I should. When in dark, walk